In question 7, we have a circuit diagram showing three resistors W, X, Y and Z connected in series with an ammeter and a battery of negligible internal resistance. The battery has an EMF of 10 volts and the ammeter shows 2 amps. In A part 1 we need to find the total resistance of the circuit. While using resistance is potential difference over current, we have 10 volts giving 2 amps, a resistance of 5 ohms. In part 2, we're told all the resistors have the same resistance. We need to show that our answer is consistent with them having a resistance of 3 ohms. Well, for W, X and Y, we have W and X in series, but then in parallel with Y. So 1 over the total resistance is 1 over the resistance of Y, plus 1 over the resistance of W and X in series with the resistances adding. This comes to 2 plus 1 over 6 ohms. Inverting gives this combination having a resistance of 2 ohms. We can then simply add this resistance to the resistance of Z of 3 ohms, giving the required answer of 5 ohms. In B part 1 we need to find the current through resistor Y. Well, first, if we find the potential difference across Z as the current of 2 amps times its resistance of 3 ohms, meaning it has 6 volts of potential difference. Y then has the supply of 10 volts minus the 6 volts. Y then has a potential difference of the supply at 10 volts minus the 6 volts across Z, giving it a potential difference of 4 volts. Then we can do current is potential difference over resistance, which comes out at 1.3 amps. For part 2, we need to find the potential difference across resistor W. Well, the potential difference across W is half that across Y because it shares the voltage with X. Therefore, this is the 4 volts divided by 2, giving it a potential difference of 2 volts.